Hi everyone, I hope you don't mind my little helper here. His name is Ted, and together we're going to have a TED Talk. Okay. So, my name is Tetiana Platonova. Some of you may know me as Tati, as I volunteer in an organization who hosts today's event. And I also currently work for this blockchain software house named AtWorks. And today we're going to talk about the importance of the clean code. My talk is inspired by the book Clean Code by Robert Martin, who is known in the IT world as Uncle Bob. And I'm going to cover just some of the concepts that he mentioned in his book. If you feel like going further and discovering bigger concept on a bigger scale concept, I encourage you to read the book by yourself. So we're going to talk about why it is important and then how to achieve step by step better, clearer code. So what is it, clean code? Basically, there are as many definitions as there are developers, because every developer can define clean code in their own way. One of the definitions that I liked is that the clean code is a good code, is like a good book. It's easy to understand and a pleasure to read. So, wait, read a code? Who's going to read the code? Exactly. The reader of our code is going to be a person who might be working with us on a project, for example, so other developer. And that's why it is important for us to have our code clean, so this other person doesn't have to spend a tremendous amount of time figuring out what does this code do, or ask a million questions to the original author of the code. The second reason we should have a clean code is for ourselves. Because as the project develops, the amount of code expands, and then later on we might have to come back to the code that we wrote a while ago, and if it's written in a messy way, we might lose the path, the logical path that we were thinking about before. To prove the point, imagine you're trying to buy a house, which is perfectly functioning house, but it has broken handles of the doors, or it has the windows positioned so high on the top that in order to open it and get a fresh air, you actually have to go all the way to the garage and bring the ladder and then climb on the top of the ladder and open the window. Sounds horrible, right? And imagine then you have visitors in your house and you have to explain all the same steps to each and every one of them each time they have to do this. It sounds just awful. So before buying such house, you might think about asking the previous owner to fixing it, or fixing it yourself maybe, in order to get the beautiful house. But as you work on a project, even if you write the good clean code on the first place, when the project extends, the code tends to get messy, tends to rot in time, and it's a natural way, and there's no way to escape it. It's a thing that happens to every developer, so there's no reason to be ashamed of it. But wait, how do we escape this? There's such a rule in a Boy Scout organization that claims to leave the campground cleaner than you found it. Applying this rule to our code, it means that whenever you return to use some kind of class or function, and you feel like, oh wait, it got too big, too messy, it's harder to understand, you might consider spending some time to clean this code. And now we're going to move from the general way of cleaning your code into more specific steps. First thing that happens to every developer, no matter what you write, is it a function, is it a class, is it a method, is it a simple variable, you name it. And naming is as important as important as everything else. And first rule of the naming is to use intention-revealing names. For example, in this particular situation, we assign the D a value of date. And let's say at this point it's pretty obvious. But then later on we pass this variable somewhere else, and we tend to forget as a person what it meant before, right? And then we'll have to go all the way up searching what was the original assignment in order to figure out what this variable means. Instead, you should consider writing the full name that describes what this variable actually holds in it. Second rule for naming would be to avoid disinformation. In this particular example, what could DC mean? Document, data collector, or day counter. There's no way to know. If you use the full name, again, like in the previous example, meaning full name, you end up understanding what this variable holds without going to the original assignment. Another rule: make meaningful distinctions. It is considered a bad approach to distinguish your variables that have similar semantical value by assigning just the numbers at the end of this variable. Sorry. Instead, you should use the full name that describes the meaning of it. In this case, first date, current date would be more specific than date 1, date 2. And I have a question actually for you, because this slide holds a little Easter egg. Who knows what is this date? No one? Yes! Yay! It's the first meetup of WarsawJS ever. September 16, 2014. Let's move on then. Another rule for naming is to use pronounceable names. At the first glance of this name, you kind of tend to think that maybe a cat walked all over the keyboard. I don't know. But then you start to see some kind of pattern. Oh, wait, there's a year, month, date, hour, minute, second. That seems confusing. And especially imagine if you're working together with somebody on a project and you discuss this particular part of the project, and then you have to pronounce this name all over again. And it's like, and what? Instead, date should be held as a timestamp, for example, is a good approach, right? And then you might consider naming the variable also timestamp creation, timestamp. For when it comes to naming classes, classes actually represent objects, and in JavaScript specifically, they actually are objects under the hood. So you might as well use the natural way of naming objects, which is noun. For example, dog. When it comes to methods, methods represent the action of this of the class of the object. So they do some actions in a natural language. We name by verbs. So use the verb for the methods as well. Like dog, what did it do? Bark. Also, there is a convention to use getters, setters, accessors, predicates with using the get, set, and is words as part of the name of the method. Excuse me. The next rule is to pick one word per concept. Say you have some kind of service that performs some kind of actions, and you decide to name it user controller. Then whenever you have another kind of service that performs similar things in some point of view in your project, you should consider using the word controller again, instead of mixing and match the controller, driver, manager, service, and all of these different things. Use different names for semantical different methods. What it means. Let's say you have a few classes, and for consistency reason, you use a method add all over it. What does this method do in this particular case? It receives a parameter and creates a new value by adding the original value with the parameter, and then returns this new value. But then when you have to, again, using natural language, when you would say add, or in other words, put something into the collection, well, it might seem like for consistency reason you want to use the word add, but then under the hood it performs completely different action. It's a semantically different method. So consider using something different. In this case, for example, insert. Using solution domain names. Well, as mentioned before, your code most probably will be read by another programmer. So don't be afraid to use computer science, math, algorithm terms, or design patterns, because there's a big chance that person will be able to understand. For example, in here, CoinMarket might seem to be good business name for some entity, but then it says nothing about what this is. What does it do? This thing? What is it at all? But when you name it CoinMarket API, it immediately tells the programmer that, oh wait, so you can actually ask for some kind of data from there, and maybe, I don't know, get the currency exchange rate or something. But on the other hand, using problem domain names, problem domain names could be also a good chance for that. A good approach, sorry. Because there are some situations where there's no programmese way to describe some point. So in this case, royalty payment, it might be not familiar to everybody, but then using the longer and explanation name for it, interest for artist payment, it's a bad solution. So it is easier to use the shorter and more describable name, even though it's a business name. And then if somebody isn't actually familiar with the concept, this person might ask some other developer or like project owner or the client for the explanation. And another point, different point that actually has to be mentioned only in non-English speaking countries is stick to English whenever writing your code. Almost every programming language is based on English language. So it is a worldwide convention to use English language when programming as well. So it applies to both not mix and match two different languages, as well as not use the different language for naming your entities at all. Now, the second point of...
Short digression.
Sorry?
There was a times when it was a fashion to provide compilers in a localized environment. I can recall Pascal, which was Polish-based.
These times are gone. Sorry. So functions. First rule of the function, it has to be small. Second rule of the function, it has to be even smaller. How do we define what is a small function? Well, the good small function is something that is under 20 lines long, and it has only 1 or 2 levels of indentation. In other words, you might hear a lot about the callback hell. That's something that you can avoid by following this rule. And another rule for the function, it has to do only one thing. It's so-called single responsibility principle. And solution, how to achieve good small functions, decompose. In other words, move some stuff around, divide them into smaller functions, and make those functions be reused. The next rule is so-called command query separation. This principle claims that a function has to perform either command or action or answer the query. In other words, question. In this example, the method set seems to not only set some kind of value to some object, but actually return true or false value saying whether the operation was successful. It's something that we want to avoid. Instead, what we should do is have this setter do its job, and then have a separate method that actually answers our query whether the operation was successful. Your functions also should not have side effects. For example, in this piece of code, when you try to log in a user, you actually verify if he's eligible to be logged in, and then for some reason you straight go to redirect into profile of this user. What? No, this is bad pattern. Instead, consider moving it outside and creating a separate method which tells us whether user is logged in, and then if the operation is successful, redirect to the profile. Arguments. Arguments is an important part of functions, and they also should be written in some following some rules. First of all, you should have as few arguments as possible. For several reasons. First of all, whenever you call the function, you will have to provide all those arguments. It might be frustrating. Second of all, the second reason is testing. If you need to write a unit test for such function, you will have to test all the test cases, and combination of the more arguments you have, the more combinations of these arguments you have to provide for as test cases, and it gets frustrating. So the less arguments, the better. If you need to actually absolutely have to pass a lot of arguments, you might consider combining them into an object or list. Another thing, you should avoid flag arguments. Flag arguments are those that return a Boolean value, which is true or false. And it's a first signal that if a function performs something based on condition, it's a signal that the function does too much. It might be destructed into two separate functions. Errors. Errors are also part of the functions, right? And we need to properly handle them as well. One of the rules is prefer exceptions to return error codes. What it means is that if some operation is unsuccessful and we have an error, we should throw this error outside of the function and let the user of the function, the caller of the function, handle this error in a more standard way, for example, bracing it into a try-catch block, instead of returning some custom string code and then have the user of the function, the caller of the function, handle it in a million ifs and go into this indentation hell. Also, error handling is a one thing, and coming back to the single responsibility principle, the error should be handled separately from the action. And extracting try-catch blocks to a separate function could be also a good approach. As coming back to the previous point, error handling should be separate. It could be done in the try-catch block outside of the function. And the most important rule that all of you probably heard of, do not repeat yourself. Write the try code. If you catch yourself that you're writing all over again at least 2 times something similar, the same things, it is a good signal that you should extract it to a separate function and recall it again whenever you need the information. Classes. Classes is a similar, is a second next entity of programming, and they actually follow similar rules to functions. First of all, class should be small. But when we talk about functions, we talk that functions should be small in a line-wise, right? But when we talk about classes, classes should be small in a responsibility point of view. So the less responsibility class has, the better. It's easier to read and understand. And the second rule is classes should follow single responsibility principle. The last but not least entity of programming is comments. Comments are as important as everything else because they provide additional information about our code, right? And has to be followed some rules to write good comments as well. For example, in this particular situations, the code does such thing that is not obvious. What does it do actually? Well, it's not described in a good way, and developer decides to describe it in a comment. This is a bad approach. What instead you should do is create a method which holds this action and name it in a way that it describes itself, because some say that good code does not need comments, right? So there are actually good comments that you might be forced to use sometimes. And one of this example is illegal comments. Let's say you use some outside library and they force you to mention reference to them in your project. So comments is a good place to do that. Explanation of intent. Sometimes you need to write some kind of code which seem like to be a bad solution at the first glance, but then there are reasons for that you're forced to use this solution, and you need to explain why you did it. So explain your intent in the comment might be a good comment as well. Warning comments. Warning comments are those that you provide for your fellow programmers. For example, do not change this code, it meant to be this way, or please don't run those tests unless you absolutely have to because they take too much time. Just help your fellow friends. To-do comments. Well, basically, to-do comments, it's something on the edge of good comments and bad comments, because some might argue if we should leave them. To my understanding, it is okay, maybe not good, but okay to have to-do comments while still developing the project. Those are references that you might use in the future, like for your future self, right? So they might be helpful for you. And JS comments. JavaScript as a not typed language sometimes needs to be explained functions that expect some kind of list of arguments, and we describe some types of these arguments, right? So JSDoc is a place to use it. There are also bad comments, of course. And one of those comments, one of type of these comments is redundant comments. It's those comments that explain something that is already obvious. There's no need to explain a lot of the things. Misplaced comments. For example, you leave a comment next to a code, and then later on you develop the project and you move this code around somewhere else, and you tend to lose the comment somewhere in the, it stays in the original place, but then you move the code, and they no longer match. They no longer are aside of each other. So you want to make sure, whenever moving the code around, move the comment as well. And again, JSDoc's comments, they might be good in some situations, but in some situations they also consider it bad code, because they create a mess in a code that is not publicly available. There's no need to describe something that nobody else is going to use, right? But the most important rule in becoming a better programmer and writing a good code is practice. Because no matter how many books you read, no matter how many talks you listen to, no matter how many videos you watch on YouTube, if you don't practice, you're not going to become a better programmer. You're not going to improve your skills. So I encourage you to write a lot of code and don't be like Sheldon. Thank you for your attention.
Questions. Who has question? I have one question.
Sure.
Because you mentioned about variable as single letter. D equals new date. In that code that I know you read before talk, I read about you can use single letter as variable in small context. When function has 2 lines of code, probably maybe a callback or something like that.
I would still say you should not, but yes, thank you for reminding me. Actually, it is a common pattern to use a single variable like E or J when you go through a loop. It's a common pattern, and everybody's going to understand what it means, so it's not a big deal if you use it, right? But then if you write something other than that, I would say it's still good to use the full name.
Exactly. Any questions? So I have one question. You mentioned about dry, do not repeat yourself. But what about unit test? When you should define the same act, the same, not act, but arrange the same setup of each unit test.
Extract it into a function and call that function in a test.
Okay.
This is a great topic. There are people are divided into 2 parts.
Awesome.
You want to have the discussion?
And they don't see any other options, and they who are refactoring and pulling up the common parts.
Awesome. Any questions? Okay.
Oh.
Okay, so in this talk I really missed the design patterns to make a clean code base. I think you should tell us more about it, how it helps to develop the clean architecture and code.
Unfortunately, I'm limited on time, so I had to cover just a small part of this, but everything is in the book.
Any questions? Okay.
On the back.
All right, so a few years ago, I was tasked with developing a rather large project that had lots of callbacks. That was the callback hell that you mentioned, and what it was right before the introduction or invention of promises. So we basically didn't have any other options. Well, what happened was we hit the issue you mentioned, and it was to the extremes. So we had like 16 or 17 indentation levels, and it was not that great, to be honest. But we had very wide monitors, so it was workable for a while. No, okay, that's a joke. But we ended up doing it the traditional way, which was refactoring into functions and then splitting it up. So you would refer to different parts of to different parts of code, but then we had a different problem that was a bit reminiscent of the go-to problem of the days of old, that you have your code very split up, and you basically, to follow the flow of the code, you don't have to, scroll in the horizontal, but what you have to do is jump all over the file and all over the project. So that would create a different kind of obstacle, and we didn't really have a way of handling that. I mean, now that we have promises and async await, that issue is kind of mitigated because your code is flat, and basically you can, just follow it to its logical conclusion from top to bottom. But the issue is very real if you don't use or can't use async, await, or promises. So is there a canonical pattern for dealing with this kind of go-to madness where you have to basically, track your way through all those functions that call one another? Isn't it just like another kind of spaghetti?
Sorry, I missed the question. To be honest, it sounds like a really complicated problem. I cannot think of something on top of my head. I might be interested in having a look at this code, which I don't promise I'm going to help you to solve. But as you mentioned, nowadays the language developed, and we have async, we have promises, we have better patterns to handle this problem. So times are gone. Goodbye.
Please give Tati a big round of applause.
Thank you.